we tried to have a link from Ubuntu, from the Linux system we tried, but even we couldn't do it. So
Yes.
we came here for Windows. And even in Linux, if we connect, we can't, Windows users can't able to connect it. That is the problem we had.
Yeah, so I think there is some issue. So it's fine. I mean, I need to take my, I went to office and took a laptop from my lab.
Thank you so much, sir.
Fine.
I think we can start the session. Let the people join.
Okay,
We'll introduce the speaker to the audience.
Good afternoon, all. Here we have Mr. Prashant Kumar Rai, doctoral researcher, Temple University, Finland. He did his Master of Computer Applications in 2019 in Pondicherry University. He have industrial R&D experience in computer vision and data-driven AI in computer vision as a data scientist for 1.5 years. Now we are going to have a presentation in the title Open Source Tools for Video Analytics. Welcome you, sir. Please.
Thank you so much. Thank you, everyone. And it would be nice if you don't call me sir. It's fine. You can.
Okay, Mr.
Okay, so yeah, it's very good afternoon to all of you. And
sir, we'll share. We'll make you as a presenter. Please wait, sir.
Sure.
Yes, we made it, sir. We can proceed. So please share your screen. Share your presentation, sir.
Hope you all can see my screen. Is it visible?
Yes, sir.
Okay. So
Yes, sir. It is visible.
So, welcome everyone and very good afternoon. My name is Prashant Rai and the title of this talk is OpenCV with Python for Visual Analytics. So I'm very happy that they invited me for this talk. So thank you, ma'am, and all the organizing committee members. So yeah, currently I'm a PhD student at Intelligent Hydraulics and Automation Group in Tampere University, Finland, which I joined in April. And before that, I was a research engineer at Clear Image AI. It's a company specializing in computer vision and neural networks. So my work is mostly for like last 3 years I am working in computer vision and deep learning, especially after my MCA, and then I joined this PhD in this year, and before that I was working for Clear Image AI and I lead several projects and contributed others which are related to design of the data pipelines and neural network training pipelines, and they have the specific camera, so I contributed to that applications also. So yeah, it's okay. So this is outline of my talk. So first I will introduce what is computer vision and vision analytics, and then the applications and with most common methods of computer vision, and then how how much Python contributed in last decade to vision analytics, and then OpenCV. I have several hands-on examples as well, and I will show you by doing things, and I have 3 use case applications which I can explain you. Then we will go to discussion. So as a scope of this talk, I kept this as simple as possible. So if anything, if you have any questions during talk, just drop in chat, or we can do that later. So, all right, so let's start with computer vision. So what is computer vision actually? So computer vision is basically like
Excuse
in case
Mr.
of
Prashant.
human. Hello.
Can you, your voice is little bit low.
Okay. Is it fine now?
Yes, fine.
Okay, so sorry, I was speaking slowly. So, so what is computer vision? So, what is computer vision? Actually, vision is very essential since like for all the living kinds. So the way they can perceive the environment and then they can navigate and operate whatever they can do. So, like since it's been like the advent of computer science, it came, and like a lot of AI came and robotics and a lot of applications came. So how we can make computers to see perceive the environment, like how they can perceive, so what way they can perceive. So whatever we can do with whatever step process we can do to perceive, to make a computer perceive the environment and analyze the information, that is known as computer vision. I listed a very simple definition here. It's all about the ways computer extract information from images and videos, because we have to program it, and it's like they we use some sensors like camera or some like stereo cameras, mono cameras, and then those cameras will just imprints those information in terms of matrix, and those matrix will later processed by the programs to. And so here we can you can see like what we see and what computers see. So what is the application area? In last decade, as I feel like in as development happens with the like this new hardware came, the graphic processing unit, and then neural networks and development of all kind of deep learning methods. So vision has been like emerged a lot in last decade, and before that also it was, but it was limited. It has limited scope in very several years, but now it's spreading like in terms. If you see in the robotics, so for performing house cleaning, or very simple example of Dyson vacuum cleaners, or there are other indoor robotics operations as well as ocean dynamics robots. They are performing different type of things. So, for doing those actions, they need to perceive the environment correctly and exactly in the both the semantic and metric way. And then that's robotics. And then document analysis. There is applications like optical character recognition, where we just put there are specific cameras. Like I was working for the companies, they have this kind of vision devices, so they can analyze the document and convert from the text document to some graph representation and other things. And so yeah, it's also very helpful. And I guess in India also, like 4 or 5 very good startups, they are working in OCR thing with computer vision methods. And this medical imaging, yeah, it's very crucial application. And I feel like this will be a breakthrough in upcoming decade, because there are disease in different levels, in X-ray. So we have systems now, they can identify disease in the X-ray images or Fondo images of eye retina. So those kind of applications, and diabetic retinopathy through the retina images. And there are other MRI and fMRI imaging techniques also. So vision is very much involved in those cases. And then it comes to sports analytics. So sports analytics also having a very big uh, application area, where so ball trackings or player tracking, or there's a lot of numbers of ways they are doing the things, and to analyzing the dynamics of game and those kind of things. So, and then retail having also a lot of applications, these days the self checkout thing, and very popular. the stores like Amazon's stores, they on China, and so you can just go there and just pick the objects, and it can identify what did you pick, and then it will bill you. So yeah, the retail applications, and then warehouses having it's having a very complex and very big, so you have to just like inventory management and other kind of things like the stuff. So there are the vision is very much involved to monitor the things and to analyze the data whatever is there. And autonomous driving is very exciting area, and it's very I mean it's the controversial also because it's now in application with several companies like Tesla and uh, Waymo, and I'm also specific like involved in this research. So autonomous driving having, because this is the case, you can't miss anything, and you have to perceive environment very correctly. You have to estimate like where if there is an obstacle in your way or a person or whatever, or so. And other than that, there are like mapping and navigation, like the slam thing, like localizing the vehicle with help of cameras. So vision is also involved in that level, and surveillance like the asset monitoring and like stealth detection with cameras. So these applications are very common these days. And then biodiversity and forest fire detection and a lot of other applications in like uh, in environmental monitoring. So it's also like as climate change is getting a like very problematic last few years. So I guess it will be also need more attention. So it's still a lot of applications are being used with drones and other. And then structural and inspections. So like it's for very big infrastructures like the buildings or dams. So there are companies, they are working in this like inspecting the like identifying the cracks or damage in that infrastructure. So but I can't list all the applications, but there are a lot of applications of computer vision and analytics like involves, because we are currently we are in data driven world, and uh, we have a lot of devices, lot of image data has been uploaded every day. So we have a huge amount of data which we can use to like solve several problems. So that's what analytics came into the light. So yeah, now I will go to, so it's very first application of computer vision, that is image classification, and this image is taken from CFAR dataset. It's a very fundamental dataset for image classifications, having hundreds of class, and they used the neural network thing to classify the images, like what image contains which thing. Like you can see here, the all the airplane images belongs to the airplane, and like finding the label, what is in the image. So so classification. So before neural network came, there is also techniques like the image processing and age detection based techniques, or different like classical techniques and hand driven features techniques. So the classification were performed there also. So it's not new, but deep learning is just accelerating this area. So but yeah, I guess like nowadays a lot of other applications came, so classification is still just a very fundamental way to test the networks and algorithms. Then we come to the object detection. So object detection is actually like finding, it's basically the classification like the semantic attribute and like localization. So it's a combination of classification and localization. So if you have a scene, or in case of this image, so here we can see this is a car, and how do we know that a car? Because we know the features of the car, like it's having headlights and tires and this is specific design. So in this image, the classification will be like usually which like what region belongs to which object. So region, and how do we find that region? So that's the localization. So it's actually like before machine learning era, it was like you have to just feed the features, and then you have to apply some classifiers to do. Then like machine learning came, and you have to just like label this thing with a box. So that's like here it's a car and dog or whatever, and then you pass that to network, and the network will learn that thing automatically from that image or scene, whatever it is. In case of 2D, it's easier, and there are also stereo cameras and lidar inputs, so which can make you the object detected in 3D, and then further it can be used to locate in if a scene given with the similar object, so it can detect that this object, and it can find the position of that object. So position, like localization. So especially in object detection, there is the box will be the output for each object, like this is a car, and this box relates with the car. So region which contains the car, the region which contains the dog. So the box usually happens by xy coordinates and the width and height. So like this image has been taken from this system, the faster RCNN, which is very, I mean, it's a benchmark, and there are a lot of different applications every day. Like comes some paper doing breaking the benchmarks, but yeah, but the basic idea is that. So that's the object detection, and now we'll go to the segmentation. So segmentation is a bit depth in the object detection. So it's actually uh, the method which classifies at the pixel level. So here, if you see this image, so this car, so all the pixels belongs to this car have been just there is a polygon created around them. They have been flood filled with some whatever color, it's your choice, you can put for some specific level. So that's there. So basically segmentation is like generally the three types, and how they can help. I mean, it will give you the exact region of interest which belongs to an object. Like if there is a person, so it will give you a polygon around person, not only the boxes. So I like the segmentation more than the boxes. So here you will like see it's can't see my cursor. Is can you see my cursor? It's fine. All right.
Yes, sir, we can see.
Okay, thanks. So yeah, so in this image it's not very clear because I took it from somewhere. It's a paper. So the basic idea of segmentation is to just find the exact polygon which belongs to an object, and that will be some specific class level. So there are like three type of segmentation. The first one is semantic segmentation, which will just give you the some object, like all the persons in this image you can see they are labeled with some red color, and then all the cars they are labeled with the blue color, and this the road and the footpath, and so there is yeah. So and this is semantic segmentation. It will just give you the semantic value of the object, very tight polygon around it. So yeah. Then it comes to instance segmentation. So in instance segmentation is also I mean, it's a type of segmentation, but there is it's more technical in terms. Like there are two things. One is called stuffs and one is called things. So stuffs are like more I guess the coarse, we can say like the coarse regions, like the sky, the big buildings, or this road. So in instance segmentation, only the things have been picked. Things are like the other, like smaller, like more fine and more crisp classes. So they have been in instance segmentation. They only have been segmented. And then the panoptic segmentation comes. So panoptic segmentation came in last, I guess, last year, 2019 or so. The panoptic segmentation, they combine these two things, the semantic and the instance segmentation and the panoptic. So here you will get the coarse objects as well as the fine objects. So segmentation is very much helpful. Like I personally I worked a lot with segmentation while I was working for the company, because there we were working on different pipelines to generate the segmentation polygons for like the mask detection and the person counting and those kind of stuffs and in parking applications. Right, now the tracking comes. So tracking is basically either you can do segmentation or boxes. Boxes are cheaper in computationally, they are computationally more faster than the segmentation. So here usually the tracking contains the boxes. So tracking is because if we have a digital video, so that's constant, that video is made up of frames, like single image frames. All the video is a temporal representation of a frame. So what the tracking does, tracking just identify and detect an object and just track that across the different frames. So there is another thing in tracking comes, so that is known as re-ID. So if you detect something in there is multiple persons. So if you have to you are in a office or you have to identify different objects, different person, if you want to put the label. The simple example is a school, like if you want to track someone. So for attendance system is very simple example. So you can just track the students and teachers, and you can just re-ID them different times. So you will, when you detect first time in first frame, you will assign ID to that, and again when you see that, so that ID will be with them. So that's known as the re-ID, re-identification, and in tracking. So re-identification is very, helpful to deploy various applications in tracking. So there are single object tracking and multiple object tracking. So there are methods OpenCV also having some inbuilt method for tracking and detection. I will explain them later. Okay, so now after tracking, the other thing comes the pose estimation. Actually, so what the pose estimation is, there are key points in if for estimating the pose. We just, because what are the, in example of human, what are the different things which cause us to be in different pose? That is, those are the joints of our body, like the hand, this wrist and this arm joint, or so those were identified at the key points. And then we can in key points, eyes and mouth also come. So and then it try to get the features in image which belongs to those points, and then it will try to join them to create a full pose, and then it can be deployed for different applications like action recognition or those kind. Yeah, this image is from OpenPose. So yeah, what are the general tools and libraries? So basically, for doing whatever task I show you, we need to go through a very basic, that is known as some. You always have to do some image processing before whatever application you want to do, and those processing is very costly in terms of computational efficiency. So how they are costly? Because the images are most of they are made up of the matrix, multidimensional matrix. So those matrix, if you do a multiple matrix multiplication, that's very complex. If you are not using some vectorized solution or something. So there are there are very in image processing. Basically, there is heavily math involved. Math is involved because not only the multiplication. If you have to detect the features, then you have to find the changes and identify the gradients and those kind of how pixels intensity have been changed in different levels. And so yeah, so the processing will be complex, and then the speed. You want solution fast. You don't want to spend 3 hours identify a ball in a image. So that is the thing. And then the higher level, the interface, how easy you want to interface, because most of the times the I mean such kind of applications, they have very uh, they already have a very heavy backend, so they can't be treated as is. So we need an interface. How do we want to access them? So actually, like OpenCV, for example, OpenCV follow all these three things. And so for basically like the math processing, and if you go for speed, you need the more hardware level programming languages to write those codes. So they are basically prefer most of it. Even I prefer the C++ or C for those applications. But everyone is not expert, and there are a lot of application people are working. So you shouldn't, and you don't need to be an expert in C++ to use OpenCV. So those kind of scenario, there are bindings like the higher level interface. Those bindings can be either in Python, and before Python there was MATLAB, and MATLAB was also very popular library. So yeah, so MATLAB, so those were the higher level. So you can simply just, if you have to just you have to read an image, you don't need to write the input routines of C++ to read that image. You can write, but if you don't know, there are options available like Python. So what Python did last last 10 years, I guess 10-20 years, whatever, Python just reduce the complexity of programs. Even non-computer non-programming background person, if they can learn Python very efficiently and very easily, and then they can apply this work. As I guess you all have been doing this like last 2 days. So mostly so you knew like how Python is good for performing different data driven tasks. And I mean, it's very good. I started learning the serious programming with Python, so Python was comfortable for me. So then we seek the libraries. So for doing this, like you have to always when you think about the application, like which is related to vision. So there is always like these three things will be belong will be there, which you will seek for. So you will seek for the easier interface to code the solution or whatever in your mind. So there are I guess a lot of libraries, because Python is open source language. So there's a lot of community support. So in case of like the OpenCV is the best and the biggest one, having most of the applications. I will explain about that later. Then I just listed the very frequent and very important ones here. So scikit-image is also like OpenCV. I guess you can came across with the scikit-learn library for machine learning in last session of Ajit sir. So yeah, so scikit-image is also library, but it's not having much much algorithms implemented, but still yeah, it's good for many applications. And then Pillow is very tiny library. If you want to just do some I mean online Photoshop thing, or just cropping the images or read write whatever very basic operations of images to compress the video or whatever. So Pillow is very lightweight library, and you can just do it very simply. And then Cornea I personally interested, because Cornea is library which is connecting the general computer vision things, which all these libraries are doing with some like neural network libraries like PyTorch. And so this is the differential computer vision library. So this is from Facebook AI research, and this is also open source, but I guess this is hardware. So I just wanted to introduce you with Cornea. Maybe I can, yeah. So this is the mean, you can perform all this, whatever the task is very efficiently with any kind of applications, and basically the machine learning application. Then we have the scikit image also. So yeah, so image processing in Python, and it's also open source and free, and it's very easy. You can see like here, tree line, you can read and apply a Sobel filter, which can get the edges of the boundaries of the objects in this image. So yeah, and below. So yeah, below is also it's very tiny library, and mostly the image processing, if that's performed in web, so they use this, they prefer in below if there is a Python backend, known as PIL, Python Imaging Library. Okay, so now let's go to okay, so yeah, OpenCV Python. So I told you like OpenCV is like it's basically written in C++. All the algorithms, they are written in C++. So there is the standalone library, the main library is in C++. There is a binding that's known as OpenCV Python. So through that binding, like few people, they just made it possible writing the bindings. So you are able to access all those algorithms with Python very easily and very like efficiently. So here you can see like it's having Java libraries, Java bindings, MATLAB interface, which is MATLAB was very popular language for I guess before our generation, before my generation, the researchers or the people who were mostly prefer this MATLAB, and still it's in use. But with like as Python came, so there is a more simpler options for people in like in case of Python. So through Python, like it support all kind of applications, basically in machine learning, fueling those applications which I show you very first, like initial of the slides, like segmentation, detection. Those applications are also in OpenCV. Like there are very classical like watershed algorithm for doing segmentation and object detection. There are HAR cascades trained in the OpenCV. So there were methods for doing all those tests, but still OpenCV is fueling the other machine learning libraries and other backend libraries which are using this vision analytics things too. So it's I guess it's a major library used by most of the applications, and it supports Windows, Linux, Mac OS, and Android and iOS. So if you want to you make a Android application also, you can make with OpenCV. There is software SDK for that, and iOS same thing. Linux it's work natively, and then Windows it also work with Windows. So yeah. Yeah, I missed this slide, I guess. So actually, OpenCV was developed in 1999. It was an internal project of Intel. So this Gary Bradsky, this guy was leading that project, and then they like after the successful of actually the story behind the OpenCV development was this Gary was responsible for university connections, like university relations. So there were he used to visit by the universities like MIT and Stanford and all those. So he saw like they have developed their own in-house libraries for to performing this visual analysis and all kind of image processing tasks. So he lead this. He started the OpenCV development, and Intel made this open source, so anybody can use freely, and they can it's BSD license, so you can either you can use for commercial like application also. So since nowadays like a lot of new startups are coming, so if you like you can still use OpenCV or such kind of open source computer this such other open source libraries to create applications or prototype, and you can pitch them to some. It's very easy nowadays, like with open help of open source, a lot of things are very easy. So we can go to maybe open source page. Yeah, so this is the page for open source, like OpenCV, and they have very well documentation. So whatever, like they have more than 2,500 applications, which are very like nobody can remember them. So documentation are very well. So you can like whatever you need, you can just go and just solve the things. I was when I was working for Clear Image, so most of the time I didn't know how to do some things. I just simply search for OpenCV, and OpenCV definitely have the algorithm for that thing, and I used, so I learned a lot. So then they have the tutorials also, and they have different courses, so you can check it later. They have different kind of things. Right. So for let's go to this installation. This is a diagram. I got it from the OpenCV documentation, and here you can see the operating systems it's supporting, which is Windows, Linux, and OS, and iOS and Android. There are so binding run here. I mean it's upper layer, and then so OpenCV having like basically it's having for nowadays. When it was older, I guess this is for high performance task like the graphics task like CUDA and all those other processor level open like OpenCL and other heavy graphic things. And then OpenCV come, which is core, and this is country. So country package you basically contains the things, because as I told you, like it's open source, and even you can make commercial application with that this library. But there are some algorithms which are heavily patented, and like the shift algorithm for doing the feature extraction, and so those are very and other few other applications. So they are in this country. So I guess like they have some restriction with the country. So I will tell you later if you are going to install like those things, like you are going to do some shift bit this feature extraction, or so you have to install this country module, because a lot whatever is missing in OpenCV, so you should go for OpenCV country for those functions. But I think it won't be needed. So there are several ways to install in Ubuntu. So so first it's very simple. You can install as if you don't have any package manager installed. Like I believe that you already have the Conda installed. So if you in case you don't have Conda, so there is always Python natively installed in Linux. So you can just go and simply install by this command. And then if you have a like other than that, you can, if you want to install this as a like Python package, which you can install. The difference, like if you install this way, so there are like some GUI libraries which are missing in Linux most of the time, or some people, like sometimes even I faced the problems like you can't be able to see the images in the GUI, because for that we need the different like tools in Linux. So if you want to like if you are you can use this way also, OpenCV Python, to install that, and you can specify the version if you want some, because since the backend is compiled, so you have to, there are several applications which like which having the limitation of like what version it should be, like what version it should be to of OpenCV, like 3.4 or 4.5 or whatever. It's like it's usually like four digit thing. So sorry I didn't mention, but you can get that for I will show you. I have code for that. And if you have Conda, then it's super easy. So you can just simply go with this command also, or the fourth option, which is very obvious for any Linux user, that is built from source. You can just, the GitHub page I showed you of OpenCV, you can clone that code and you can build it. So what happens, like when you are working for some like non-traditional applications, like you are working for some application special hardwares, like these days the NVIDIA Jetson and Raspberry Pi, if you want to build the OpenCV for them, then you have to, there are some things which are disabled in the like the like the configuration list. So you have to enable them for that platform, and you have to, like, if you are working with some GPU based machine, so you have to enable the GPU thing so it can access the GPU libraries and all the graphics backend thing. So yeah, so you can build from source, but Windows, there is either you can download and install it, like I guess there is a executable version of OpenCV Python, or you can you need to install Python, and then you can install, like, whatever way you install the thing in Linux. It's the same for this is the Python thing. So if you have Python, you can install in this way on the Windows. Conda, then Conda, it will also work there. Even in Conda also, in Windows there is easier, because there is something called Anaconda Navigator. So you can go, you can in GUI, and you can search for the packages you want, and then you can just install it from there. So that's also a very easy way to do if you are not a very terminal friendly person. Sorry, I think I missed the Mac, but fine. This is mostly the same thing, like this way that you can install, because it's natively if you have Python on Mac, you can install it. Otherwise, but said I didn't did it. Fine, you can find it on the, I will share link to the maybe the code. Okay, so these are the modules which are available in OpenCV. So as I told you, like, it's having like more than 2,500 algorithms roughly. So there is something called core module, where you will the image read, write, and basic color change, or whatever you want to do, the blurring and other things. So those are in the core, having the data type of images and the pixel properties and whatever other things, like the it's more related to the, I mean, the backend thing, the C++. So it will, you have to, if you want to check the data type of image, or type of image, or like the type of pixels, their intensity. So those operations are core, or the operations where, so this is image processing module. So image processing module having all the basic thing, like the blurring and edge detection, or whatever, smoothing. There are a lot of applications. So all the basic image processing thing, they are in this module, and which are like connected to this core thing. And then this high GUI is usually for like showing the image, and because OpenCV having a specific GUI, which if you try the show function, so it will show there images. And then there is a video module. So reading videos, like reading videos from the camera, or if you have some remote camera, so you can just give the address of that. So it's also like it can read even the camera of remote machines, and or you can pass a video file to that. So I will show those things. I have course for that. And then the calibration 3D. So it's for usually it's for if you have a studio camera and you are working on some 3D applications, like 3D object detection. So basically in 2D camera, it will because the world is 3D, so it will just map those things to a 2D image. But if you are trying to do get those 3D information back, like the depth of the image, depth of the scene, or the shape of the, like the size, height of the object, or so then you need to perform the calibration. You have to find the focal length of camera, and so it's the OpenCV is very helpful when I use like sometime to calibrate my sensors with OpenCV, the vision sensors especially. So you can get the focal length and the center of the image, so those things. So it's very helpful. So I mean, and yeah, this the features today. So features is, it contains the feature extraction tools. So there are several algorithms like Raja and Sitomasi and all those. I won't go in depth in that features thing, because that's something in higher level. That's one thing. And then object detect, so it's for object detection, it do the object detection based on the R cascades, like there are pretense weights. So those are in XML, so you can load them from the OpenCV library and you can detect objects. You can specify that. And then ML is like, it's a newer module which contains all the classifiers. You can perform the regression and classification in images and other things like related to machine learning to images. There is Flan. Flan is very nice library. So it's also like fast library for approximate nearest neighbor. So this is for performing the nearest neighbor operation in images. So it was very successful library, and I guess it's in use by a lot of applications of pattern matching in images and like signature matching and all kind of different document analysis or such kind of applications. It's still in use. Even I used this when I was at Pondicherry University. So yeah, this then CUDA module is there for communicating with because GPU CUDA is it's C or C++. You can say it's compiled language. So this is for creating graphic applications and processing. So specifically it's been used if you have a NVIDIA graphic card, then you can run to harness the power of that card to parallelize the graphic task. That GPU is only for doing the large calculations in very nice way, which you're performing the parallel task. So like your processor do the sequential, and so GPU are very that NVIDIA every year I guess they are rolling like 3-4 GPUs, and even they roll like GPU based smaller machines also, like the Jetson and other machines. So CUDA module, so OpenCV you have access to CUDA module also. You can perform operations and functions. And then DNN is for deep neural network library, so you can create the layers of your neural networks, like the hidden layers and the output layers and all those kind for like image applications. You can use OpenCV for that. And then photo is, I guess it's been merged into someone, but it's related to Photoshop thing or mostly, but the algorithms which are not in the image process. Then stitching is especially for like if you know the concept of the panorama which are in modern smartphones. So those like the panorama is basically the image stitching, like taking two images and then stitch them to create a single image, like a bigger image. So that thing is in stitching, and it's also because you have to match the features from one image to other image, and then you have to combine them. So it's pretty complex task. And then contrib. So contrib is also the patented algorithms are there. So there are you can use for your personal application, you can use contrib for free. But if you are making some commercial application, I guess there is something, some restrictions will be there. And there is non-free version, which I guess you have to pay for that, or you have to get license for using those non-free modules. So OpenCV is very huge, and since you can see it's been started in 1999, and it's still now it's pretty mature. It's having a lot of support, and I guess at the moment it's having more than 50,000 of contributors in the OpenCV community, and they are whatever problems you will get, you can easily go and ask them. They have their forum page on the OpenCV, which I shared you. So those are the modules of OpenCV, and then go to the right. So maybe I can show you those. Show you some. having some German keyboard which I bought from the lab. So, yes, so this is very, I mean, you are familiar with this way, like how to import them. So in case of OpenCV, you just need to like and simply import OpenCV. Now it's imported, so you can see the version. So I am using the latest version. I guess it's 4.5.3. There are sub version also, so you can check, but that's minor version, so that's not important most of the times. Okay, so yeah, now we will I'll show you how it's reading the images. You can see it's very simple, and just put the image here. This is by the way, I use Matplotlib for like plotting in Jupyter Notebook because it was. But I will show you. You can do this I mean cv2.im. So here it's like for reading image, you can simply just call the im read, and then you can pass the image path, and then it will read. And so by default, it reads there are like red, blue, and green. There are three channels in. If you are if it's a color image, then so OpenCV read that in order of BGR. So blue will be first, and then green, then red. So there's nothing to worry about them. But if you want, if you are going to perform some things, you want to change color or whatever. So there are routines also. You can call them to change the color. So you can just. So I think few libraries they use the RGB, like the PIL and scikit image. They load into the RGB, and then the OpenCV do that in BGR. So most of the times, if you are working on some big applications, so you have to, for performing some I mean in some functions, if you are calling an RGB image and you get BGR image, then it will, the channels are reversed, so you will get some error. So there are functions so you can use to change the channel. So now we'll go back to slide and okay. So now yeah, I just show you. Sorry, someone's mic is on, I guess. Okay, so yeah, image types. So generally, whatever we read the images, they are basically treated as I think you might be familiar with NumPy because it's third day, so you must be familiar with the NumPy. So the NumPy is in Python. NumPy is very basic library for doing all those I mean heavy array methods and vectorization or whatever you want to do. So that OpenCV will read your image as a NumPy array. So you can, if you will try to check the type, so you can get like the NumPy array. So yeah, here these are flags which are very basic. Then so I added them, and so this is the image color. So you can see like this. It is specify the load to load a color image. So if you are loading by default, it use this. If you want to use some, if you have a PNG, because PNG having a channel, so you have seen like transparent background. So their background are transparent. So you have to specify this. If you want to use, so you have to either pass the 0 in case of 1 because it's a, I mean it's like binary value. So 1 is for true and 0 is for false. So you can pass the false if you want to access that channel, the transparency channel. So by default, it will read you the BGR, and then you want to change it to the grayscale. So then you can simply call the grayscale function, and so it's for the image read. These are the path and the flags. You can every function having the flag, whatever you want to, what way you want to do. It's pretty flexible. So you whatever task you just specify the task and go for that. So you will get the function and everything. So you can do it very well. right? So now, yeah, the pixel types. So as I said, like this VGR, and so there are color spaces like so when I mm, like the color images having three channels, VGR, RGB, whatever it is, the red, blue, and green. I will show you in the code. I have the code for those things. So and then HSV is like it's kind of more depth thing there. It will deal with not the colors, because sometimes if you are handling with some different scenarios, like in computer vision, whatever deep learning is doing, why that comes, because before also the image processing was good and they were doing, but there was some scenarios where the those like the like if there is no light, like the object will not be same. That's why the computer vision is hard. Even neural networks also face many challenges. If you I mean if you train if you want to detect a bottle which is I mean from single side you detected that that is bottle, but if you want to check for another side, it might be different in the texture and the color. So those kind of problems is there. So this color space can help in the, so hue is actually the color, and it happens with modern, I guess, the photo editing tools where those kind of color spaces were used to make the image more enhanced in terms of color. So this the value is lightness and the saturation is the amount. But grayscale, I mean, this is single channels, you can say it's binary, like there would be only black and white pixels. So yeah, so this thing I already explained. Yes, so basic operations, I will show these operations here in Jupyter. Okay, so yeah, so this thing is working, and you can see this is the image, and now try to run this cell. So yeah, so now you have this object, the image object, image color. So let's check the shape of this. So shape is that actually this is the 434 is the height and 640 is the width. Always is the OpenCV shows like height, width, and HW and channel, number of channels. So we have 3 channels. So let's scale.
Excuse Mr. Prashant, can you zoom the screen? Can you zoom out?
One second, I'm just doing. second, I want. Trying to zoom it from the second laptop. Sorry for that. Can you zoom it from here? Is there any option to do it from WebEx?
It's fine now.
Can you see this?
Yes, yes, we can see.
Strong. Right, so now it's, let's check the channel. Check the channel out. So here there is no channel, so I mean it's binary image. So you will just see the 434 by 640 height and width. Size, size will be just the multiplication of both these things. So I mean, how many pixels do you have? So it's something, because it will be, then it will be like a matrix of row and column simply. So, and in case of 3 channels, it would be like a cube, and like whatever, there would be 3 channels involved with that matrix. So each pixel having 3 colors, and here it will be only one value. So the type of so the type is numpy ND array. I mean ND means n dimensional. So if you have more than one dimension, then okay. So yeah, this is the computer like CV OpenCV routine for showing the image. So you have to write this thing, and then you have to write, because then it will generate the G. Let's it's Jupyter having some problem with that black and white GUI. It's not. I am so. I mean, Jupyter having like this thing, like you can't load the native OpenCVs, so that's why I use this PLT. But sometimes it works, sometimes it didn't. So whenever you are using Jupyter, so use Matplotlib, because Matplotlib is very good Jupyter, so it's having plugins. Let's try not to use this. Start the kernel. So when you want to see this the image in OpenCV, so you have to like use this thing, and then you have to give this command. It will wait for any key. You can specify that key for like what key you want to press to close that. But it's if you don't like if you put 0 for wait key, then it will wait for until you press any key, and then you can destroy all windows, like you can kill all the windows. In those windows there is option for saving the images also, so try. Now I want to write this image, so this is the good way you can save images this way. Started. So if so this true, it means your image has been saved with this name. So whatever function you want to call or do, you can just so read, write, and so these three things have been. So now you want to access the pixel of the image. So let's access the pixel at x and y. So these are x and y positions. So x and y are basically the width and height. So you have to just put the coordinates. Those are basically coordinates. So that didn't matter if you have a 3-channel image or you have a single channel image, whatever it is. So that point you have to pass that point for accessing that pixel. So now we pass this. Let's change. All right. So now we got the pixel. So we will print the value. So here you got. So this is BGR. So if you want to like, let's go. This is the blue edge 186. So which is, I mean, the first channel, and then you can put the second channel. I mean, it follows the basic listing of like list property of the Python 5, and then so whatever you want to, you can even put the loop if you want to get all the pixels. That also I'm doing later, so I will show you. You can assign the new color also to that pixel. So and so here we have this blue color, and this function is for make border on the image. I'm using this like the make border routine of the OpenCV. So replicate, I mean, it will replicate the same image with these are actually the what I'm giving the what will be the size for both like all the sides. Then reflection. So then like, I mean, it's writing the borders on the all the four sides and basically doing this. So maybe I think it would be visible or not. So here you can see it's very. So here you can see the border. So I have converted that value BGR to RGB. So now we are getting this red. See if we can change the color. Because now we are using a now you can see the blue border around them. I will share this notebook also, so you can try it later. So then you have this, I tried printing the first 10 pixels value. So I just did the list method for like doing this from the image. I'm accessing the first 10 pixels and then printing them down. And now again, what I did, I took this point, whatever it is. So, and like it's for whole row, for a single row, I am getting all the value of pixels and I am then visualizing them here. So you can see the row, that row, you can see the green, like which pixel location and what, because all the pixel locations contains its a RGB image, so all the 3 channels, so you can visualize them here. So those are the things you can, like, it's very basic, and I guess it's a blur thing. So this way you will see the GUI. So it's blurred now. You can see this picture is more sharper than. So there are like setup function. Now if you want to do the blur manually, then you have to write a tons of code, and like, so in that case the library is best, and OpenCV having all the things. See, I just explained whatever I. Yeah, so these are the references. I mean, this Learn OpenCV is very nice blog from the OpenCV. So they publish every week. They publish a lot of good practices in computer vision, and so it's nice to follow. And then OpenCV having their own tutorial, and then like I basically learned from this course, the computer vision. This is from Stanford, and this is free course. So you can go there, and you can. So this is if you are interested in computer vision, because this is only 1 hour talk, and you can't be like expert in 1 hour for the computers. You can be introduced, and then you are interested, you can go for this. So this course, it's not using OpenCV, this huge scikit image, but this course is very nice, and you will get familiar with all the things involved in computer vision, whatever functions and how to do all the processes. So very nice course. You can access lectures and notes from here. And then we have.
Can you please share the links?
Yeah, sure. I will share the slides, links, and I have 3 case studies codes in GitHub, so I will share everything.
Okay, thank you, sir.
Yeah, it's fine. And then below having the documentation, and then PyImage search. I really like this guy. PyImage search, and a lot of people, if you have worked ever on the vision applications, because this guy having a solution for everything, like whatever task you are thinking of, he has a tutorial on that. So you can simply go and check his blogs. He is very famous. Adrian Rosbrock. He write everything about the computer vision, and he having courses also. So it's very nice place. So you can get full blogs for free, and if you want to get certificates, you can get some paid courses also. I'm not sure how costly or cheap. I guess they are cheaper. And this is free code camp having. If you want to get into computer vision, few things you have to know. Like those are the mathematical applications, at least the geometrical thing, and then the. You don't need to be expert. You just have to be familiar with them. So those things, how you can do this with the Python. So this is known as scientific computing. So if you want to go with the fundamental of computer visions, so all the things they are built upon this, only these things like the linear algebra, calculus, and whatever it. So there are libraries. You don't need to worry about the functions. So you just need to learn about those libraries, how they work actually. and the OpenCV also having the home. So how much time do we have?
Ten more minutes we have.
Okay, so I think I will share you the, because in 10 minutes I wanted to show you the examples. Maybe I can. Yeah, so these three examples we prepared thanks to, I will share the GitHub link of all these things, but maybe I can show you here. Let's go with the land detection. So I'm with the Visual Studio. First, I will show you the. So this application will using only OpenCV for detecting the lane boundaries in the road. Okay, so now we have a video file. So we will, you can see we imported all the required libraries, OpenCV or the matplotlib. So yes, so we have to pass just the, here you can see the cap is creating an object which will capture you the video. So args videos, we will pass that video file, which is by default this one, and then it will take the video and then it will split that. Every time if you have a video you want to process that with OpenCV, you have to loop it through the, most of the cases is while loop, because it's a continuous video. So the read method, so you created the object. Now with this help of this, you will just read the frames. So it will give you the frame, all the frames, and then you can use those frames to whatever you want to do, like row, columns, channel. Row is basically the height and the columns are width, and then channels are the channels. So the shape, you can see all the methods I show you. Then you can create this polygon. Yes, so let's run this. Don't have. So you can see like it's detecting the lanes of the road. So have you seen, like in, I didn't write the code more than 30-40 lines. Of course, there are a lot of things, but it's still, you will able to detect the lanes in a video. So how easy it is. So then I guess it will be 5 or something. So it's very simple application you can do. There are a lot of other things we can do. So I have those codes. I will share these things to you. One of my friend created that thing. So I have everything in the GitHub. I will share that link to you. Maybe I will share that link here in the chat, or so you all can access that. And I haven't uploaded my slides there yet. So I will upload them. So I'm sorry, like if you have any questions, you can just talk.
Participants, any questions?
Any questions?
There is no question.
Prashant,
Yeah. Ma'am,
Prashant,
just before
yeah,
just one
yeah,
second.
yeah.
Yeah, ma'am, since it's a faculty development program and I have also like studied there. I mean, so I mean there
Okay,
are
one
faculties.
thing,
So
it's not a
I just
question.
no,
I
ma'am.
have some clarifications from you.
Okay.
What motivated you to work with this video analytics? And what do you
Uh,
think that how things will change in future? So, what's
I
your
mean, yeah,
perception? I
ma'am.
would like to
Yes, ma'am. So, like, I was just, I mean, I did my bachelor's in mathematics and physics, and I was interested in like robots, and I haven't had chance to like read. I couldn't get into the engineering, but then I came to Pondicherry University, and then I got interested like Ajit sir and Kuppusamy sir. Kuppusamy sir used to write a blog in Open Source for You magazine. So I in my very first semester, I got a blog of him explaining the deep learning, what the deep learning is actually, and then nobody knows Python that time in our batch also, and most of the our seniors also. So we request Ajit sir to take the session on Python, and he agrees. And it was his last year, so he took Python. So I learned Python from there, and we had a like then I mean me and like Kupusamy sir guide me a lot, and other faculties also, and Ajit sir. So I came into touch, and then I got the things like how I have to get enter, because I was already interested in artificial intelligence and robotics. And I took one other course like AI and expert system of Shanti Bala ma'am. So that course was also nice. So I mean those things were like entry point for me. And then I took a lot of courses from Coursera, because then deep learning specialization came, and I want to do since the robotics there is a lot of deeper thing, like there is control, there is perception, and there is like knowledge based thing. A lot of different things are involved, communication and other things. So perception was good for me, because control needs a lot of which actually not interest me. I mean I don't know in future, but perception was easier for me, so I just wanted to get in. And I started computer vision, and then I did my minor and major project what on this. And before my major project, I got this the Clear Image AI, and I was second employee there. So I crafted the pipelines for them for data, the data augmentation, and then distributed neural network training and those things. And then I had this choice, like I had this thing. I mean, when I was in university, I didn't plan for PhD, but I wanted to explore more in this area. So now I'm working in autonomous driving, and the area I'm working, which is very important because it's basically belongs to heavy duty machinery. So in this, like the place I am, Finland. So here like they face very severe weather challenges in winters, so they don't see sun for like 6 months. So those kind of things, like the machines, they won't work in different scenarios. Like there are a lot of development in passenger vehicles like Tesla and all others, so they are working with cars, but no one is thinking about this kind of use cases where we can just automate them, and we can just reduce a lot of, I mean we can make them more safer, and we can boost the productivity. So that was it. I mean, there was a lot of people involved behind me to get me here. I can't like tell everyone, but I'm learning. So when sir told me, so few days back I took a Atal FTP workshop. So I told him like I just took the workshop. So he was like, you okay, now you are speaking. I mean,
okay.
but it's nice, ma'am. So it's nice to be here. Yeah.
Actually, I am very happy to have your session in this workshop because generally in all the workshops, everything will be delivered at the highest level, maybe at the conceptual level. So when this workshop, when it was sanctioned to me, I had in my mind that I have to call only the people who are working in the area so that they can give that exposure to all our teachers. Generally, the teachers we will start and we will not go up to this level and we will ask the
Yes, ma'am.
students to do. Okay. But if I know it very well, definitely that is going to be helpful. We can guide the students in a better way. Keeping that in mind, when I discussed with Dr. K.S. Kupuzami, he immediately referred your name. And first of all, I have to thank you for that, accepting this and coming and giving a very, because I can say only the informative session, but the people who are really working, definitely they will come to know the value of this session. Earlier sessions were from Dr. Ajit Kumar, okay? He introduced all those things and how all the skyscape that he has taken, okay? So I hope now the participants would have got using that Python, how the data analytics is being done. That is the
Yes, ma'am.
motto of this particular FDP, the first part. The second part starts with R. That is from tomorrow. So,
Yes,
Habiba, is there anything else or you conclude?
Yes, ma'am.
ma'am. Just one thing I want to say. I mean, since there
Yes,
are faculties, so I just
yes,
want
yes.
request. I mean, in if in such kind of domains like the data-driven analytics and those, so only reading theories or studying theories won't help much. So at least we should like include the hands-on thing, so students can, because I have also given these sessions to like different places also. So people ask me like how to do data science without programming. So it's not possible. You can't do things if you don't know. At least you need to know some high level. So just please, I mean, I request to just involve the hands-on learning more into the courses, or and design courses in such a way that can give the practical. Uh, Thanks.
Yeah. The session, like you people who are currently working, definitely because you're working in one direction. But this FTP, you have to again get into the higher level, think about it, and you have to deliver the session. In that way, definitely, I appreciate the effort taken by Mr. Prashant Rai for this FDP. So, as a coordinator, definitely I have to thank this time Dr. Kupuswamy also for referring your name, and I have to thank you for accepting and giving this session to the FDP participants. I hope the participants of this FDP up to this session they would have got all the hands-on experience, and really when we are working with that application, what we have to do and what we have to give it to the students. And he gave a nice suggestion also. Definitely, all the teachers who are attending this particular workshop, you can think about it, including it in the way you would like to craft or you have to design your course. Okay. Now, I'm handing over to Habiba to formally thank the speaker and conclude the session.
Yes, on all behalf, I thank you very much for your clear and detailed presentation on video analytics. Thank you so much. We'll have an photo session. Please all switch on your cameras. Mr. Prashant, you can press you. Please, participants, switch on your cameras, please. Yes, thank you all. Thank you.
Thank you.
I will share the links to the email, and then you can get those links. All my slides and the notebook and the boards. Thank you so much, and have a good day. Thanks, ma'am.
Thank you.